nr by gamma minus 1 T1 minus T2, and then use ideal gas equation for the first equation, P1 V1 minus P2 V2 upon gamma minus 1. These three formulae we have got work done in adiabatic process. We have not derived the work done for polytropic process. Yeah?
Just replace the gamma by beta.
Where?
In the previous part to get the polytropic one.
That's right. Because the formula wise it will come the same. Although what you are saying is right, but yet I would like to derive it formally in another way. Remembering it that way is fine. You will get, maybe we can write it down and derive it a little later. P1 V1 minus P2 V2 by gamma, this is valid for this part, which will be, instead of gamma replaced by beta. Instead of having P per gamma as constant, we are having P per beta as constant. The formula will be derived similarly. So we'll put that formula there. Rather, both the formulas will be valid, okay? This one will also be there, nRT1 minus T2 by beta minus 1, like that. Yeah, okay. We move on to the Q column. Can we find out what is the heat transfer each of these processes? What is it for this one, Q?
NCV delta T.
Yeah, you can see it that way also. Otherwise, delta U plus W is Q. This column plus this column should give you this column. So that is one formula anyway. So here this plus this, that way also we can see, yes, it is NCV delta T. What is this one?
NCV delta T.
That's right, NCP delta T. And if you add the two, you can notice that CV plus R is CP. That's the Mayer relation. What about this?
Infinity.
The same thing. Cut and paste. What about Q?
Zero.
Q value for adiabatic process. Well, that's the definition of, since dq is 0, total the integral dq will be 0. And the Q for polytropic process is what we had found out, NC poly delta T, where, let's recall this once again, C poly is R by gamma minus 1 minus R by beta minus 1. Okay? So let's recall the state variable relations for all of them. Isochoric process, state variable relation, what is that?
P by T is constant.
P1 by T1 equals P2 by T2. Next one. P1 by T1 equals P2 by T2. We've done that already. Three relations for this. In PV, in TV and PT.
PV gamma, PV gamma.
Yeah, and especially remember the PT one. Normally I find students mistaking that. Tell me the PT one. Pressure, temperature.
P gamma. Is equal to constant.
P power 1 minus gamma. T power gamma is a constant. You write it like this. T1 V1 power gamma minus 1 is T2 V2 power gamma minus 1. P1 V1 power gamma equals P2 V2 power gamma. Then P1 power 1 minus gamma, T1 gamma equals P2 power 1 minus gamma, 2 power gamma. And finally, the state variable relations for polytropic process.
That's the same thing with just gamma replaced by beta.
Yeah, same thing, replace gamma by beta. That's right. Same thing, replace gamma by beta here. So let's write it once more. T1 V1 power beta minus 1 is T2 V2 power beta minus 1. T1 V1 power beta is P2 V2 power beta. T1 1 minus beta, T1 power beta equals P2 1 minus beta, T2 power beta. We have got the last column. We have to draw the PV graphs for all of them. What's the PV graph for isochoric process? Vertical line, horizontal line for isobaric, isothermal, rectangular, hyperbola, and for adiabatic, steeper. I'm just writing the word steeper here. You understand what I'm talking about? Okay? Or rather, we can write the slopes there. That will be helpful for us. Let's write down the slopes. What's the dP by dV? You can write the dP, the slope here is dP by dV. That equals minus P by V in this case. Whereas here dP by dV is minus gamma times P by V at any given point. And you can't draw this because that depends on the value of beta. So I'm writing that depends on beta. Well, that's it. Look at the chart. Remember it. And that will help us do the questions on thermodynamics. Yeah, so shall we start with a few questions now? Have you taken down the chart? Are you comfortable with each and every box of the chart? Each and everything we have derived from scratch. Nothing was assumed. Yeah, shall we proceed? Yeah, shall I rub it off? Yeah, so first question. A thermally insulated vessel of nitrogen, a thermally insulated vessel of nitrogen moving at 10 meter per second at 27 degrees centigrade is suddenly stopped. What is the rise in temperature of the gas? And I would prefer to get the answer in general terms. Specific, don't give me a specific answer, that's just for your information I put that way. Give me the answer in general symbols. Molar mass by V square by 2 CV did you say? Let me check it out. See, what have you applied? See, this vessel of the gas is moving, so if it was stopped, then that means let's take the gas in the vessel as the system. The dotted portion represents the system, the gas in the vessel is the system for us. So first of all, from mechanics, you can understand that there was some external force employed. If the vessel is moving, you've got to stop it. If you're stopping it, there is some external agent doing work. So if you do your work energy theorem, the work done by external force equals delta K. That's the only force acting here. What's the change in kinetic energy here?
Half mv square.
Final energy is 0. Initial energy is, let us assume n moles of the gas. And let m be the molecular mass of the gas. So total mass of the gas is nm v square. Speed of the gas. This is the decrease in kinetic energy of the gas. Final stops initial. We are talking about the kinetic energy of the center of mass of the gas. We are not talking about the total internal kinetic energy of the gas. That is anyway there. Molecules will be flying here and there. That's when we're doing initially also, finally also. So, if you apply the FLT on the system as a whole, applying FLT on system I have shown by the dotted line, you get Q equals delta U plus W. It's a thermally insulated vessel.
Q equal to 0.
That means what is Q?
0.
Q cannot enter it. So delta U equals minus W. This is work done on the system. So that way also it's negative from our understanding. So your work done on the system will be minus half nm v square, and this is equal to NCV delta T. For nitrogen, what is CV? It's a diatomic gas.
5 by 2 R.
5R by 2. 5R by 2 delta T. Well, that's it. Solve this to get your answer. So you get the answer as delta T equals, can I say 2 gets cancelled, mv square by 5R.
I'm the way to see.
Is it okay? That's the change in temperature of the nitrogen. It will shoot up by that much. You can of course substitute and check it out later. Let's drop that right now. Anyway, if you substitute these values, what is the value of m you will take?
28 grams upon into 10 to the power minus 3.
Yeah, just be careful on that, because in chemistry you're used to putting 28. This 28 10 to the power minus 3 kilogram. R will be 8.31 in SI units, and you get your answer. I proceed to the next question. Can we? Next question. Write down. Nitrogen gas undergoes isobaric heating. N2 is isobarically heated such that work done by the gas is 2 joules. What is the heat supplied during the process? W gas will be equal to what? This is the isobaric heating, is you can say P delta V, but you can also say some of the formula.
NR delta T.
Yeah. That happens to be 2 joules. And what are you looking for? What is the Q? What is the formula for Q?
NC CP delta T.
And Cp delta T. So if I divide the two, I get Q by W gas is equal to NCP delta T by NR delta T. And then cancel. Well, can you solve this? Huh? Is it 14 or 7? Cp is 7R by 2. 7R by 2 into R into W gas. Well, that's the answer, which you can substitute to find it as 7 joules, okay? The next question. Hydrogen gas is present in a sealed vessel of 5 liters at STP. It is cooled by delta T equal to 50 Kelvin. It is cooled by delta T equals 50 Kelvin. So what is delta U and Q for the process? What kind of a process is going on? Okay, that's the first thing you infer. It's an isochoric process. So if it's an isochoric process, what are we looking at? What will be delta U equal to? Well, for any process it is NCV delta T. Do we know the N? Yeah, exactly. Use that idea that 1 mole at STP occupies 22.4 liters. So 5 liters will be how many moles? So we can write 5 upon 22.4, okay? Do we know CV? Yes, of course, it's a diatomic gas. So we can say 5R by 2. Alright? And delta T is how much?
50.
No, it's not 50.
Minus 50.
Yes, respect the negative sign, you can't say it's the same. Minus 50. Alright? So we calculate this and you would get this roughly about 250 joules. I think it's 232 something, but let me round it off and say around 250 joules. If you have a better answer, I can write that down. What is Q, by the way? Same. Ditto. Because W is 0. Finish. That's all. Question over. Next question. 2 moles of a gas initially at 300 Kelvin is first of all cooled isochorically such that initial pressure becomes half of itself. Thereafter, it undergoes isobaric expansion such that final temperature equals the original temperature. What is the total heat transferred during the process? Yeah, 300 R, that's the right answer, yes. It's now about 2500 joule. I think that's what you will get. Rather, the first thing you draw is the PV diagram. Maybe you did it without that. Did you draw the PV diagram? We can make it visual. So, if you start with some pressure P0 here, now from here how should I draw the diagram? Cooled isochorically means what? I should go up, down, right, left, what? Down. I go down like that. That's the process 1 till you reach half the temperature. Sorry, half the pressure. And your temperature here happens to be 300 Kelvin. Do we know the temperature here also? What's temperature here?
150.
It's isochoric process, pressure becomes half, temperature becomes half. 150 Kelvin. Thereafter what? You have isobaric expansion. Which way do I go from here?
Right.
Right. And till where?
till temperature becomes equal
But
to...
how will I know when does temperature become 300? When temperature becomes double, volume will also become double.
2V0.
Isn't it? It will be going till 2V0. Is that okay?
Yes, sir.
Let's say the black terms are inferred terms. This is 2V0. This is inferred. This is given in the question. So I won't call it inferred. This is given in the question 300. And this is also given that the final temperature is again the same as initial temperature. The two black ones are the inferred, what we have found out using our background and properties of the processes. And we want to find out what? You want to find this Q1 plus Q2. That's your Q total. Do we know Q1? What is Q1? NCV
So
delta T.
Delta T is 0 for the whole
150.
process, equated to the work.
What are you saying? Yeah, you can do that also. You can find the work done and do it, but right now I'm wanting to get the idea of the process. You can do it that way also. Here I'm doing for each process separately. NCV T2 minus T1 is minus 150 and Q2 happens to be NCP T2 minus T1 is plus 150. So what we notice is this is NCP minus CV times 150. N happens to be 2 for you. So your final answer is 300. CP minus CV is R using Mayer's relation. 300 R, so we leave it like that. That's the answer. Alright, so take up this question. You have a 1 mole of a gas inside this vertical cylinder at temperature T. There is a weightless piston there and you have an atmosphere outside. You have a weightless piston and an atmosphere outside. The question is, what is the external work to be done such that, rather what is the work done, external work done isothermally such that volume of the gas inside the vessel becomes eta times. Volume of the gas inside the vessel becomes eta times. So tell me, see, in any such question, we use this idea of work energy theorem that net work done by all the forces on the piston is 0. In all our questions, we assume that the piston moves very slowly. We actually call these as quasi-static process. So two things happen. One is this, the other is the net force acting on the piston is always 0. The piston will never be accelerating, it is moving very slowly. So, and because the piston starts from rest and comes to rest, total change in kinetic energy is 0, work done by all the forces is 0. These are two of the main problem doing strategies. So here we are applying this one. Let us see. In this process, work is done by which forces? There are at least 3 of them. The gas, external force means you got to pull this piston. This piston is slowly pulled out such that the volume of the gas becomes eta times. So you got to apply that force on the piston. And as such, the atmosphere is also doing work. So what you are interested in is this answer. This is your target unknown. So we got to find out these two to get this result. So now let us look at this. What is the work done by the gas here? It's 1 mole of the gas. So you can say 1 RT log eta V0 by V0 is log eta. Is that okay? And what is the work done by the atmosphere? What kind of a process is the work done by the atmosphere?
Minus P0 eta minus 1 RT by P gas.
No. Why are you going at